Hello friends, welcome to the third and the final part of integrating RTI with IBP order-based planning. In the previous two series, part 1 and part 2, what we have covered is setting up connectivity between IBP and the BTP sub-account. In the second part, we have completed and shown how to configure Cloud Connector and integrate Cloud Connector to the execution system as well as to the BTP, and as well we have shown how to create the inbound communication scenarios in IBP that communicates to the cloud connector via the BTP network. Now the last and the final part of the puzzle that we will cover in today's demo is the RTI outbound, how to set up the RTI outbound communication 0684, 0685, how to set up this communication and how to ensure that movements of transactional and configuration data from IBP to ECC happens using the outbound communication scenarios, and through which we can basically publish results of IBP back to ECC or S4 HANA via the cloud connector. Now, before I show you how to create the SAP communication arrangement 0684 and 0685, there are a few prerequisites that we need to complete in ECC or S4 before we can start setting up this communication. One thing that you must remember is when we created the inbound RTI connection, the user ID that we have used in the inbound connections were the user ID that we created in SAP IBP itself. And that same user ID we have used in the SM59 RFC connection so that the user ID authentication could happen properly, and IBP, being the receiving system in an inbound RTI connection, will receive master data and transactional data using the user authentication that we have created in IBP. Now, in case of outbound, it is just the opposite. Outbound means IBP will be requesting or sending data to ECC or S4 via the cloud connector. That means in this communication arrangement, we need to define a user or create a user that already exists in the execution system. And it cannot be just any user. We have to create specific user of user type and assign specific roles to them. So this is what the prerequisite that I'm talking about. So what I will do is I will show you what kind of users needs to be created along with what roles they should have in order to have a proper outbound integration. Now if you look into my screen, I am on the execution ECC system, wherein I am on the transaction SU01, that is the one that we use to create users. So here we have already created a user. So this is the user that I have created, and if you see here, this is a user type of type 3 or RFC user, and in the logon data, if you see, the user type is system. So this user that we are talking about should be a user type system, and along with that we need to ensure that in this user we have assigned these roles. So these are standard roles. For example, if you see, there are 3 roles assigned. One is a standard SAP SCM RTI Mentor role, and there are 2 other Z roles which I have copied from the standard standard RTI roles, that is RTI config and RTI main. I have just copied it to create a Z role and I have assigned it to these users. So without this 3 user authentication or role assignment, the RFC integration won't be possible. So this is the user that you need to create in ECC, and along with that, once you create the user and the password, you need to take a note of the user and password as well, because this is the user and the password that we will be defining in the outbound communication arrangement of 684 and 685. Now coming back to IBP, here if you see I am into communication arrangement now. If you see here, I have before this demo already created the two communication arrangement for 684, communication arrangement for 685. And if you look into the communication system or the system, although they are targeting to the same execution system, but I have created two different communication system, RTI for 684, RTI for 685, and there is a good reason for that, which I will explain, because without this the SIF integration will not work. As a result, we might face issues. So that is why I have bifurcated this into two parts. Why, I will show you. So first let me walk you through the communication arrangement 685. So if you see, this is the communication arrangement 685, where we are using a particular communication system that I have created, RTI. Then it's a standard nomenclature of the logical system ID it is connecting to, and the communication ID 685. Now once I go to display here, the system, the way I have configured the system is, when we create a system for outbound, we need to define a host, a port, a location, cloud connector location ID, and client details, instance number, etc. Now from where will we get this information? This information comes from my cloud connector. So if you see this cloud connector, the area that I have highlighted, the first part before the colon is ECC, this is the host, and the last two digit is the port number. Now here if you see, in the general data I have used the same host name SBECC. Logical system you don't need to define. HTTPS port is always by defaulted to 443. This is the cloud connector location ID, which I have already shown you in part 2 from where you can get it, so I have put that. Now here in the RFC settings, if you see, the target host is the same SBECC that I have got from the cloud connector. Instance number is the port number that I was showing here in the cloud connector. So the actual port number is somewhere in the internal host, which we do not need to expose due to security reason. So that is why for this internal host we have a virtual host and port number, which cloud connector will automatically map without exposing the actual IP or the host of the ECC system. And here that is the reason the instance number is 09, and in the ECC system I know that we are going to connect to this logical system which has the client copy ID of 020, hence this client 020. And remember one thing, for communication 685, when you create a communication system, you should not enable fast serialization. So that is the reason why we have separate communication system for 684 and 685. The communication system for 685 should not have fast serialization, so that is why it is unchecked. Scrolling down, in the user for outbound communication, here we have mentioned the user ID and password that we have created here. This user ID and password is being used in this communication. So that's how we create the communication system for 685. Now inside the communication arrangement, you have to give the name of the logical system that we are going to connect to, and I have shown you in the previous video from which table in ECC we can get this information. It is available for in the table T000. And once you select the communication system, automatically by default the user of the communication system will be populated. Now one more thing in 685 is, if you see, this communication is used to integrate or extract currencies, factory calendar and UOM from execution to IBP, and the application protocol is RFC via the cloud connector. So this means this communication arrangement connects first to BTP, then goes to the execution system via the cloud connector RFC method. So this is why this extraction of configuration data is a part of outbound integration. Now moving on, once we have created communication 685, now it's time for creation of the communication arrangement 684, which is for sending outbound transactional data from IBP to the execution system. Here if you see, the communication system is different. I have created a different one, and the reason is, here I have enabled fast serialization. So for outbound transactional data, fast serialization should be enabled. Without that you will get BGRFC or QRFC error. The host name, the port, the location of the cloud connector, client, instance, target host, everything remains the same as per the system that we have created in 685. Only difference between those two systems is 684 have fast serialization check on, whereas 685 doesn't. So this is the main reason why in the outbound connection we are having two separate systems for two separate communication scenarios. Now once that is done, at this point of time, if you see, we have created all the inbound outbound communications and arrangement, and at this point of time the linkage between SAP IBP, BTP, ECC or S4 and the cloud connector all are now completed. So technically this completes the technical integration of the IBP system, of the ECC S4 HANA system using cloud connector and BTP as a medium of integration interchange. Now with that done, before we start moving in or start sifting data and getting data to IBP or from IBP back to ECC, there is one more step that we need to, there are a few more steps rather I would say, that we need to take care of before we can start and successfully send master data, transactional data or get configuration data from ECC to IBP. Now what are those? That is what I will show you. Now furthermore, we need to create one more user which is called BGRFC user, that will be used in a loopback connection that is basically required in order to monitor my BGRFC queue in ECC or S4 system. And since we are using background RFC, so this step is mandatory, because without that the background queues won't be registered and the safe movement will not happen from ECC or S4 HANA to IBP. So for that what we need to do is we create a user. This is just an example of the name of the user that I have created. You can have any user ID name of your choice. The user type will be system, and in the roles, although I have selected many roles, one thing you need to remember is this user ID need to have roles that have authorization of S underscore RFC. So it is mandatory that it have authorizations or roles that have the authorization object of S underscore RFC, because without that, this user ID won't have the required authentication or authorization to be used in the loopback system that I will show you that how I have created, and in turn monitor the BGRFC queues. So once that is done, now I will take you to SM59. In SM59, I have created a logical connection. I repeat, logical connection. It's not an ABAP connection. Why logical connection? Because this connection technically doesn't have any host, target or anything. It is a loopback connection or a local loopback connection to enable monitoring of queues. So if you see, I have created a logical connection called BGRFC supervisor, and inside that, if you see, there is nothing apart from the username and the password of the BGRFC super user that I have created along with the client 202.0.20, and along with that there is no other technical details, because this is a logical connection. Here we don't need to give any host name or anything. So once you create and save it, the only way to authenticate it is whether this user ID has the required authorizations or not is to do a connection test first. You see, the connection test is successful. So this basically says that this user has the required authentication, and furthermore you can also go and test for authorization test as well. So both says that the user has the authorization to run this logical back loop connection, which in turn will help me monitor my BGRFC queues. Now once we have created that user and this logical connection, we need to assign this connection to the supervisor destination of BGRFC. This might be a bit technical and this is mainly done by basis, but since this is a part of the RTI communication, hence I am basically touching it here. So for that you need to go to SPRO. Under SPRO you have to go to SAP Native Weaver, SAP Gateway Service Enablement, backend OData channel, because this entire RTI is OData based, connection settings to SAP Gateway, and here you see you have the option create BGRFC supervisor destination. The moment you come, you will basically come to this screen BGRFC configuration, and in part 2 of the video we have done quite a bit of the configuration in terms of scheduling the inbound scheduler, defining the inbound destinations, giving the prefixes and all. Now we have to do the define supervisor destination. Here you have to basically, first time when you do it, you have to go and create new, wherein in the destination you put this BG supervisor RFC supervisor destination, which is nothing but the logical system that we have created. Once that is done, once this is done, we are all through with the integration of RTI for IBP. Now it's time to test both the inbound and outbound connections. So for that, in order to check the outbound connection whether it is working or not, and even before we go there, one small thing I would like to cover is, when you create a RTI based planning area, so what I have done here is I have copied SAP 7F to a planning area, called RTI POC. This is just a copy of the SAP 7F planning area. And in the planning area, once I have basically copied the planning area, activated it, I also need to ensure that I have also successfully created the integration RTI integration profile, so that the system knows that the RTI flow of master data and transactional data need to come and sit under which order based planning area based on the integration profile. So for that, we have to go to real-time integration profile. And this is the integration profile that I have created. So if you see in the integration profile, what you will get here is you have to define in the integration profile the planning area, which I have defined, the version, the base version, the logical system of the SAP IBP system, which we have already defined at the very beginning of the integration as IBP CLNT 100. Then we select the inbound system. So the inbound system automatically gets populated here based on the communication arrangement that we have created. So here, since we have only one execution system mapped, hence in this RTI integration profile we have one source logical system. But here we can have multiple logical system based on different communication scenarios, and that's how you can connect multiple ERPs to a single order based planning area. So this is the inbound system, and this inbound system gets auto populated based on communication arrangement. Here, since this is for the testing, for the transfer modes I have for now disabled purchase requisitions, sales order confirmation, but I have enabled planned orders and stock transfer requisition, so because that is a part of the demo that I need to cover. And you see in the outbound queue prefix I have used CG0. The reason why I have only select CG0 is because if you come back to ECC and go to BFI1, sorry, my bad, it's CFI1. Here you see for this logical system the queue prefix I have selected as CG0. Here we have the option to select multiple queue types. We can create multiple queue types, which would be required generally when we go into a production environment. But as of now, here since I have selected one prefix of CG0, so here I have just selected one only. And in the outbound system, it also gets populated from the communication scenarios. So the inbound communication scenarios populate the communication system here. The outbound communication scenarios basically loads the system here. So this will be, once you go here, you will go and get that option. You don't have to type it, it will be available as an option, and you put it here and you check and activate the integration profile. That's how the entire integration is now complete. Now it's time for us to check if the inbound and outbounds are working. So to check outbound, the best way to check is to run the standard RTI application job. So this is a standard RTI integration job to integrate calendar, and currency from the execution system. So here the source logical system, as I was saying, it will auto populate, and I will bring in currency, factory calendar and all. I will schedule the job. You see this, this has already started. So while the job is in progress, similarly I will also start doing a CFM1 and CFM2, or generating or activating integration model. from ECC so that we can see the inbound communication as well. So here now I will go to /n CFM1, which is to generate integration model, and here already I have some variants created. So first we will send the material and the plant. So in this case I have just selected materials and plants, and in the logical system has to be this IBP client 100, and I execute it. So there are 17 master data, material master data, 3 plants. I generate. Now I will go to CFM2 and activate this integration model. So let the integration model get generated, and in the meantime let us take a look where we stand on the integration of the configuration data. You see, as of now it is showing unit of measure has been successfully integrated, and it will now integrate currency, factory calendar. Factory calendar takes the most of the time because number of factory calendars are more. So here in the meantime, if you see, the CFM2 or the integration model has been successfully activated, and we have, the log says we have successfully moved the material and location to the IBP system. Let us validate that. And in order to validate, let us go to general response planner, view locations. We'll select the correct planning area, and you see the 3 locations is now successfully integrated. We have these 3 locations now in IBP. Similarly, we can go and check for product location combinations as well. So this shows that my inbound integration has worked successfully, and the SIF is able to transfer master data from the execution system to IBP system. So this is a validation that the inbound connection is working, and this application job that we are running is a validation that outbound connection is also working. If you see, the job has finished successfully. It has brought in all the planning calendars. From here you can see the list of the planning calendars that has been updated, and this basically concludes that the outbound connection with RTI is also working. Thus closes this 3-part series of the RTI integration, wherein we have shown in details all the components, steps, configurations and inputs that are required from each systems, and how to integrate RTI end to end and integrate any on-premise execution system, be it ECC or S4 HANA, to IBP order-based planning with flexible master data by leveraging Cloud Connector, BTP. So that concludes the end of this series. This is all what I wanted to cover. Hope you enjoyed this video. Please do subscribe and like if you like this video. Thank you.